And that's one of the quotes from his speech, and I want to emphasize, in ways that are more sustainable and even indefinite. So the question is, how do we live in space indefinitely? How do we get to a point where we say we're from Mars, that we live on Mars, or some other celestial body? And how do we how do we stepstone out to the solar system? That's the subject of today's presentation. So in response, NASA created this framework called the Journey to Mars. And what it amounts to is a plan and an architecture of how we can eventually get to Mars and live on Mars. And as Bob Cabana said, there's 3 phases which he mentioned. On the left is Earth reliant, and that's where we are today. All of our activities involve going to low Earth orbit. We're doing research on the ISS that is helping lay the groundwork. Some of Joya's systems are operating on the ISS, growing plants. But of course, for some of the ISRU folks, there isn't any regolith on the ISS, and the ISS is 0G. It doesn't have like 1/3 G, so it doesn't do everything we need. Now the proving ground is the space basically in between Earth and Mars, where we'll prove out new vehicles, new systems, and you see Orion. Orion is designed to go to the moon. These various systems that will eventually take us to Mars. On the far right is Earth independent. That's where we need to be. That's our goal. And we want to be able to reliably live on Mars. And how do we do that? And that's the discussion today. So as a historical analogy, the European settlers to this continent didn't bring over all the food and all the building materials and everything they needed to construct a life in the new continent. They brought over tools in very small ships. And likewise, we're not going to go to Mars in Battlestar Galacticas with everything we need to live forever. We're going to go in small spaceships with tools. And these are the tool builders. And so, and why do we need to do that? And I'll talk about that. But the main motivation is it's very expensive in mass to put something on Mars. For every kilogram on Mars' surface, we have to have 225 kilograms out on the launch pad. So there's a very brutal calculus of mass, of mainly propellant, getting the delta V's we need to get to Mars. And on the other side of the coin, Mars has abundant resources. So why take all the mass you need? Why not create it on Mars? So and we call this pioneering, by the way.